Hello everyone, myself Dr. Amit Kumar Yadav, Associate Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal, Telangana. Today we are going to see unlocking machine learning secret. Here we will see how model makes decisions and why it matters for student researchers and everyone who relies on AI. Why do we need to understand our model? Trust. Without understanding, it's hard to believe a model output, especially in high stake decisions. Fairness. Hidden biases can be unnoticed in black box model, which lead to unfair outcomes for peoples. Considering improvement, knowing what drives a model help us refine it and unlock better performance over time. Insight, interpreting model can reveal patterns in data. So we can say here before first trust. If we don't understand model, we can't confidently rely on it. Second, fairness. Hidden biases can exist, and without transparency, they go unnoticed. Third, improvement. If we understand what drives prediction, we can refine model effectively. And finally, insights. Sometimes model uncover patterns that human would never detect on their own. The mystery of black box. Modern machine learning models are incredibly powerful, but understanding what happened inside them is one of the central challenges of AI today. In another word, we can say that modern machine learning models are powerful, but they often behave like a black box. We give them data, they give us predictions. But what happens in between that mystery we aim to solve. What inside the black box? Imagine a super smart program that learns from data. It can predict house price, customer behaviors, or whether a student might need extra support. But how does it actually reach these predictions? The internal logic is often hidden, even from its creator. That's the mystery we are here to solve. These hidden models are called opaque or black box. The problem with opaque models. When we can't see why a model make a prediction, serious problem arise. Can't verify fairness. We can't confirm the model, treat all groups equally without understanding its reasonings. It cannot fix error. If model make a wrong predictions, we don't know where to look or what to change. Can't build trust. In education or healthcare, people have to understand and trust a recommendation before acting on it. In another word, we can say that the lack of transparency creates serious challenges. We cannot verify fairness, we cannot fix error easily, and most important, we cannot build trust, especially in critical fields like healthcare or education. That's exactly why explainable AI is essential. Accumulated local effect ALE plot. Seen big pictures, how a single feature shape a model's prediction reliably and efficiently. Now let's move our first interpretability tool, that is accumulated local effects or ALE plots. This helps us understand a single feature's influences predictions. What are ALE plots? ALE plot ALE means accumulator local effects. It reveals how a single factor like number of roots affect an output on average. They are faster and more reliable alternative to older techniques like partial dependence plots. Key advantage: ALE plot handles correlated factors features correctly. They won't mislead you when features are related to each other. ALE accumulated local effect handles correlation features, work locally unbiased. PDP partially dependency plot assume feature independent, use global average. Can be misleading. So we can say here ALE plots shows the average effect of a features on the model's output. For examples, how does number of rooms affect house price predictions? The key advantage is that ALE plot handles correlation features, making them more reliable than older method like PDPS. How ALE plot work? Here choose features split into interval, measures local changes, accumulate changes. By focusing on small local changes rather than globals, we can say that ALE plot shows the average effect of features on the model's outputs. It focuses on local change, not global assumptions. They divide data into intervals, measures small changes, and accumulated them. This avoid misleading interpretation and give a more accurate pictures of features influences. Reading of an ALE plot. The x-axis shows the range of values for the chosen features. Example, house size in square feet. The y-axis shows the average change in the model's prediction as the feature changes. The slope, a steep upward line, shows a strong positive effect. A flat line, here the features has little influence. Quick interpretation guide: lines goes up steeply, features strongly increases the prediction. Line is flat, features has minimal effect on prediction. Line goes down, features decreases the prediction as it increases. ALE plot in actions. So this illustrate the figure shows a typical ALE plot. What it means: as features value increases along the x-axis, the model prediction output rises along the y-axis, revealing a clear positive relationship between the features and the predictions. So we can say here, as features increases, the prediction also increases, showing a clear positive relationship. SAP dependence plot. Going beyond average, exploring how individual predictions are shaped by each features, one data point at a time. Unlike ALE, which shows average, SAP shows individual predictions. What are SAP dependence plot? SAP means simply additive explanation, a method rooted in game theory that assigns credit score to each features for every single prediction. SAP dependence plot shows how a feature's shape value changes across its full range of values, revealing both average trend and spread of individual effects. So SAP is based on game theories. Unlike, uh, unlike ALE, which shows average, SAP shows individual predictions. Anatomy of SAP dependence blocks. X-axis the value of features being examined. Example age, income, test score. Y-axis the shape values for that features, how much it cost. Prediction up or downs. Each dot, one individual's data point, one prediction, placed at its features value and SAP value. Colors. Point are often colored by second features at potential features interactions. So we can say here x-axis give features value, y-axis contributes SAP value, each dot one data point, color, and other features showing possible interactions. This gives us details and dynamic view of models' behaviors. SAP dependence plot examples. Each dot represents a single prediction. The color gradients reveals a second feature's value. When the patterns of color is not random, it signals that the two features interact in the model's decisions making. In another word, we can say that each dot represents a predictions. If color form patterns, it means features are interacting, giving us deeper insight into model logics. Features interaction heat map, finding hidden connections, visualizing how pairs of features work together to influence a model predictions. What are features interactions heat maps? So here features interactions. Machine learning models don't just consider features in isolation. They often pick up on how features work together. This is called feature extractions. For example, the effect of outdoor temperatures on energy use might depend heavily on time of days. Neither features alone tells the full story. Heat map makes these predictions visible at a glance using color intensities. So we can say here some features make only a sense when combined. For example, temperatures and time of day together affect energy uses. Heat map is used to visualize this relationship clearly. How to read features interaction heat map? In a heat map, each cell represents a pair of features. Color intensity shows interaction strength. Brighter cell means stronger interaction. areas we should investigate closely. So, in summary, for we can say that it inspect, grid, read color, find strong pairs, features, interactions, heat maps. Each cells in this grid correspond to a features pairs. The intensity of the colors encodes the strength of the interactions. Brighter sets demand closer attention. As the reveals bare features joint drives the model prediction most slightly. Put in all it together, no single tools tells the full stories. The real powers come from combining ALE plot, SAP dependence plots, and interactions heat map into one complete interpretation workflows. So, interpretability toolbox ALE plot. Here, this is ALE plot. It shows the average effect of a single features across its range. It is reliable when features are correlated. SAP dependence plot shows individual features contribution for every prediction plus hints of features interaction through colors. Interaction heat map. It clearly visualizes the strength of interaction between all features, um, revealing hidden models complexity. Together, these three tools transform a mysterious black box into transparent, trustworthy, and understandable machine learning models. To summarize, ALE plot shows average effect, SAP plot shows individual impact, heat map shows features interaction. Together, they transform a black box into something we can understand, trust, and improve. So, so we can say that ALE plot, SAP dependency plot, interaction heat maps are the uh, you can say that foundation of explainable AI. Without this, we cannot use explainable AI. Therefore, we can say that explainable AI is not just a technical tool, it is foundation for building trustworthy intelligence system. Understanding model is no longer optional, it is essential. AI, your future is smarter. A beginner guide to understanding artificial intelligence, what it is, how it works, and why it matters for you. What is AI? Anyway, let's start simple. What exactly AI? Is it robot? It's science fiction? Actually, it's something much more practical and already part of your daily life. Imagine a smart helper. AI, it means artificial intelligence. It is a super smart computer program that can learn, recognize pattern, and make decision on its own. It's not magic or science fiction. It was built by real people using data and clever instruction, which is called as algorithm. It learns. It means AI improves the more information it receives. It decides. It uses pattern to make predictions. It's built by people. Humans design the rules and provide the data. In another word, we can say that think of AI as a smart helper. It learns from data
just like you learn from experience. It recognizes patterns and it makes decisions. But remember, AI is not magic. It is built by human using data and algorithm. AI is all around you. You interact with AI every single day, often without even realizing it. Here are just a few examples from your daily life. Say navigation app, Google Map, Waze use AI to reroute you around traffic in real time. Recommendation: Amazon and YouTube suggest content based on what you have already watched or bought. Smart Assistant: Alexa, Google Assistant understand your voice. So we can say here you might not notice it, but you interact with AI every day. When you navigate app like say Google Maps, when YouTube recommended videos, or when you talk to voice assistant like Siri or Alexa, that's AI in actions. AI is already part of your world. From the moment you wake up to when you go to sleep, AI is quietly working in the background, making your apps smarter and your life easier. From other word, we can say that from morning alarm to bedtime scroll, AI is quietly working behind the scenes, making app smarter and your life easier. So AI is not the future, it's already here. How does AI learn? Now the big question, how does AI actually learn? It all starts with data. AI learn with data, which is just a fancy word for information. Think of it like studying for test. The more you study, the better you perform. The more data an AI is exposed to, the better it becomes at spotting patterns, making prediction, and improving its accuracy over time. So we can say here AI learns from data, which simply means information. Just like studying help you perform better in exam, more data help AI improve its accuracy. Example: teaching AI to spot cat labeling. Show thousands of label cat and non-cat photos. Features learning: AI learns ears, whiskers, and fur features. Generalization: AI correctly identify a new cat photos. This process, called supervised learning, is one of the most common way AI is trained. Label guides the AI toward the right repetition, build confidence in its predictions. Data in, smart out. Here we can say that thousands of label dog and cat images are fed into AI models. The model studies the image and it identifies key features and it learns so that it can tell us the difference. Give it to a brand new photo and it know exactly what it is. In another word, we can say here, feed in lot of data, AI learns patterns, produce smart results. Simple concept, powerful out outcomes. Algorithm, the AI recipe box. Algorithm means here step by step instructions that tells the AI exactly what to do with all that data. Just like recipe guides a chef from raw ingredient to a finished dishes, an algorithm guides the AI from raw data to a smart decision or predictions. Here input raw data goes in, algorithm rules are applied, output a smart results come out. So we can say here algorithms are like recipes. They tells the AI what to do with data. Input goes in, rules are applied, and outcome comes out. Just like cooking a dish from ingredients. AI in action. Now let's look at where AI is actually used in real world. Computer vision teaching computer to see. AI can identify object, face, and even emotion in image and videos, sometimes better than human can. Self-driving car use computer vision to detect road, roads, pedestrian, and other vehicles. Doctor use it to spot diseases in medical scans. Security camera use it to recognize face. In another word, we can say that computer vehicles visions help machines see. Self-driving cars detect routes and peoples. Doctor use AI to analyze medical scans. Security systems recognize faces. AI can sometimes even outperform humans in visual tasks. Natural language processing talking to computers. Natural language processing is a say, branch of AI that helps computer understand, interpret, and generate human language in all its complexity. Chatbot AI-powered chat assistant that answers questions and solve problems 24 into 7. Translational tools instantly translates between dozens of languages with high accuracy. Voice assistants Siri and Alexa understand the voice and response. In another word, we can say that this is how computer understand language. Chatbot answer your questions. Translation tools break language barriers. Voice assistants respond to your command. This is called natural language processing or NLP. AI seeing and speaking the word. Robot visions in factories, AI guided robot arm sorts, assembles and inspect product with incredible precision. No eye required. Conversational AIs, chatbot powered by NLP and hold realistic conversation, answer support questions, and even write essays. So here AI doesn't see, it communicates. In factories, robot work with precision. In app, chatbot hold conversations. AI is becoming both a viewers and a speakers of the world. Generative AI creating new things. Generative AI doesn't just analyze, it creates. It can produce brand new text, image, music, and even working code, often indistinguishable from human-made content. Chatbot writes essays, answers questions, and generates codes. Mid-journeys create stunning artwork from a text description. Suno Udio generate original music in any styles. So here generative AI is one of the fastest growing and most exciting areas in technology today. We can say here this generative AI it can create text, image, music and even code. For example, Chat GPT can write essays and tools like Midjourney generate artwork. AI is no longer analyzing, it's creating. The futures is AI power. So what does the futures look like? AI for good solving big problem. Medicines. Here AI helps scientists to discover new drugs which is used to detect disease earlier than even before. Climate. AI model predict weather patterns, wildfires, and rising sea levels to protect communities. Farming. Smart sensors and AI help farmers grow more food using less water and fewer chemicals. So we can say here AI is helping solve big problems in medicine, early disease detection, in climate, predicting disaster, in farming, improving efficiency. AI has power to improve life worldwide. Think about fairness and bias. AI is only as fair as data it learns from. If the training data reflect human prejudices, the AI can report or even amplify those biases, leading to unfair outcomes for real people. Biased data. AI trained on unfair data reproduces those biases. Lack of diversity. Team building. AI must reflect the real world. Transparency. AI should be able to explain the decisions. So we can say that AI is not perfect. It trained on biased data. It can produce unfair results. That's why we must design AI carefully with fairness, ethics, and transparency. You are the future creator of AI. The people who build tomorrow AIs are in classroom like yours today. Your curiosity, creativity, and sensitivity of fairness. Here's the most important part. The futures of AI will be built by people like you. Your ideas, your creativity, and your responsibility will shape how AI is used. Your AI adventures start now. AI is one of the most powerful tools humanity has ever created and is just getting started. By understanding how it works, you are not just users. Now you become creators, innovators, and responsible leaders in a world shaped by intelligence machine. Learn, understand how AI works. Explore, try AI tools and experiment. Create, build something new with AI. Lead, use AI tools and fairly. So we can say that AI is one of the most powerful technologies even created. So don't just use it. Learn it, explore it, create with it, and lead responsibly. Your AI journey starts today. So we can say here AI is not just technology, it's an opportunity and the future's in your hand.